Welcome to the lecture on levels of measurement. In this lecture, we'll be looking at different levels of measurement and exploring it through the idea of running a candy store, because that is something that I would always love to do. So let's take a look at this. So the candy store that we're opening today, or that we're running, is called Sweet Life Candy Store. And we're going to be looking at how levels of measurement can help us to run our Sweet Life candy store. So there are four different levels of measurement. There's nominal, ordinal, interval, and ratio, and that is what we're going to be exploring today. So by the end of this lesson, what you're going to be able to do is list and define the different levels of data, which we just mentioned. You're going to be able to explain what can be done with data within each level of measurement. You're going to be able to explain the characteristics of data within each level. And also you're going to be able to categorize variables into one of those four levels of measurement. And this is really important because without knowing what the different, what your data that you're working with is, you will not be able to know what analyses you can do with that data. So this is a really important concept that is fundamental or foundational for everything else that you're going to be doing in this course. First, we have nominal data. Data recorded is represented as such as labels or names. We talked about this in the last lecture, such as like eye color, SUV, the state that you live in. It has no order. It can only be classified or counted, although I might say that Wisconsin is better than Texas. Unless I quantify those differences, they can't actually be ranked. And now you might go and drop my class because you like Texas so much more than Wisconsin. But that's not the point. So nominal data can be classified or counted, and it indicates differences. That's the characteristic. Nominal characteristics are that it indicates differences between them, not necessarily ranking. For example, in our candy shop, we organized our candy because we want people to be able to come in and go into different areas of the candy shop and know what kind of candy they're going to find. So we utilized nominal candy or nominal data, where we classified our candy as hard candy, chocolate candy, jelly beans, or gummy candies. And depending on the classification that they received, they got put into a different part of the store. So, and you can look at these and you can say, oh, how are these qualitatively different? Well, they have gummy characteristics, they are jelly beans, they contain chocolate, or they are hard. So, now we need to categorize our clients to best aid our efforts in catering to each client. We know that different clients have different needs. So what's the best way to categorize? These are the four major categories of clients. You look at these, and how will these categories help us? Okay, so you have one parent with a kid, grandparents with the kids, couples, two parents with the kids. And getting into more statistics, once you look at all of these four different categories, you're going to be able to look at these categories and say, okay, what time does this category come in? What type of candy do they eat? Do they have different buying habits, if you will. One parent with a kid, especially dad with their son, I guess I'm speaking from experience. I would go in there and probably give them more candy than my wife would. Grandparents with the kid would probably give them even more candy. But couples aren't necessarily going to have the same type of candy preference. They might be buying, chocolate as compared to a parent with a kid might be buying a sucker. But that's what statistics are going to do for us. So the next one is ordinal, based on relative rankings or ratings of items based on a defined attribute or a qualitative variable. So these are measurements that are only ranked or counted. So you can classify them, count, rank, and they indicate difference, and they also indicate the direction of difference. So if you remember, nominal indicated difference, they classified and counted, but this one indicates difference and the direction of difference, and then ordinal, you can also rank them as compared to nominal. So, for example, you recently realized that your Google rating for the Sweet Life candy shop took a huge hit from a 1-star rating. They said that the candy shop was the filthiest candy store that they have ever been to, placing them far below any other candy store in the Waco area. Thankfully, they got the wrong store, so you were able to get the rating removed. Because they said the candy shop. See, they went to a different shop. That was a shop down the street, and that candy shop is disgusting. You were able to get that rating removed, and you're still the second highest rated candy shop in Waco. Right behind Hey Sugar. I don't think anyone's beating Hey Sugar anytime soon. You put together a survey, for instance. This is another way to determine, another way that you can use ordinal data in your candy shop to determine how much your customers like new candies to see if you will keep them. For instance, have them say, I hate it, I can tolerate it, I'm indifferent towards it, I like it, I love it. This would be ranked or ordinal data if you had individuals fill out a survey. Okay, so exercise. Your cash register is at the front of the store, and you want people to walk through the entire store before checking out. How can you utilize ordinal data to help accomplish this? So you've got the cash register. I should also say that the door is right next to the cash register. What can you do to utilize ordinal data to help you lay out your store better, to make sure that people walk through the entire store? Well, you can rate your candies. Use that same rating system that you did before, and the individuals that are the candy that's the best, put it in one corner. The candy that's the second best, put it in the other far corner. The third best, put it in the other far corner, and the fourth place, put it in the other far corner. And it's going to force individuals to go to all of these different corners in order to be able to get these candies. And if they go to all these different corners, then they're probably going to pick stuff up along the way. And you're like, oh, that's silly. But the truth of the matter is, grocery stores and gas stations do this all the time. That's why the sodas are in the back of the gas station, because they know you're coming in for the soda, and you walk past the hot dogs, and you walk past the potato chips, and you pick those up along the way. Or you go all the way to the back of the store, the grocery store, to get your milk, but then you stop and you get everything else along the way that you didn't realize that you needed until you saw it. And so it's kind of sneaky, but stores use this all the time in order to be able to help their business. So, back to the Sweet Life. Interval data. The distance between values is meaningful. It's based on a scale. With a known unit of measurement, you can classify and count, rank, and add and subtract. So it's just as strong as nominal and ordinal, but even stronger because now you can add and subtract because you're dealing with real numbers. The first two were qualitative variables. Now these next two are going to be quantitative variables. As noted before, the nominal data can indicate differences between the variables, between the data. The ordinal can indicate direction of those differences, and then the interval data can also do the amount of difference because it has real numbers. For example, you found a scoring system to gauge the proficiency of your workers here at the Sweet Life candy shop. A 100 is the desired goal, but they have the ability to get all the way up to a score of 180. The numbered scale helps you determine the employees that can lead and those who need extra help. And so you implement this exam, and you are able to actually organize your schedule so that way weaker employees can be paired up with stronger employees so that way they can grow in their candy shop, their sweet life candy shop experience. Temperature is another commonly used example of interval data because there are meaningful gaps between the temperature readings. Also, the 0 really means absolutely nothing. So that's something that I didn't really mention before. That's the characteristic that's really important is in interval data, 0 is really kind of meaningless. It doesn't really mean a void. And also, is 40 degrees really twice the temperature of 20 degrees? No. Is it really twice as hot? Is 120 really twice as hot as 60 degrees? Unless there is one system that, 0, is it Kelvin? I believe that 0 Kelvin is absolute 0, but that'd be the only one. Other than that, 0 is just a relative number. And that's one of the characteristics, which is everything that I said here. Also, you can count the occurrences. You can determine which temperature occurs more often. You can order the values of temperatures. And then you can add and subtract. Like, for instance, you can say, it's 20 degrees or it's 80 degrees warmer in Texas than it is in Wisconsin. Right now, when I'm recording this, it is currently 40 degrees warmer here in Texas than it is in Wisconsin. And I kind of wish that I was in Wisconsin. Can you tell that I really love Wisconsin? Okay, moving on. Back to the sweet life. Ratio. Ratio is the last and the strongest level of measurement. You can do a lot. You can classify, you can count, you can rank, you can add and subtract, multiply, and divide. Because these are real numbers that have a real meaningful interpretation of 0. They indicate differences, direction of difference, amount of difference, and has an absolute 0. Just like, all of the previous ones before, but even more. So, for example, you deal with ratio data more than any other type of data. You have the number of customers per day. 0 is a meaningful number. You still could have only 0 customers all day long, but 0 is an absence of customers. Money, time, distance from other shops, number of orders placed, or pretty much anything with a meaningful 0. So here's an idea. You are thinking about opening another shop. What ratio data should you consider in this decision? What ratio data should you consider in this decision? Okay, let's think about this for a minute. Money. Is your current shop making money? If your current shop is making money, how much money are they making? What is your profit? What is the distance of the new shop from the old shop? Is there enough of a clientele base that you are not going to dip into your existing shop as compared to the new shop? My wife and I went to a sandwich shop today, and we realized that the sandwich shop that we went to, I forget what it's called. It starts with an S. It's downtown. Schmaltz, I think, yeah, Schmaltz Sandwich Shop, and we really liked it a lot, and we wanted to have sandwiches more often, but we don't live in downtown Waco, and we realized, oh, there's another Schmaltz Sandwich Shop, and it's 15 miles away from here. That's great. Now we can start going there a lot more often, and so they picked up clients because they looked at, okay, if we put a Schmaltz Sandwich Shop right next to ours, it's not going to help us. We need to put it far enough distance away that we're not dipping into our current clientele. We also need to make sure that it's in a demographic area with, an income area that supports this. For instance, Target will only put their stores in certain demographic areas that they know individuals will be able to afford their products. Same with Walmart. They're not going to put their stores in locations where they know they're not going to be able to make money. So, in summary, this is a graph, if you will, of what these different levels of measurement can do. Nominal can classify and count, and it can also indicate differences. Ordinal can classify, count, and rank, and it indicates differences and the direction of difference. Interval classify, counts, ranks, and you can add and subtract. And it can indicate differences, direction of difference, amount of difference, and finally, ratio data does it all. If at all possible, try to work with ratio data as much as possible, but sometimes you can't. There's a lot of statistics that utilize nominal data. You're going to have to deal with qualitative data mixing with ratio data. But then some people try to take ratio data and they try to make it into nominal data, or they try to make it into ordinal data or interval data, and you kind of can, but when you make ratio data into something less than what it is, you take away from a lot of its power. And we'll get into that a little bit later in the semester, and that's just more than what you need to know right now. But I hope that this lecture was helpful. Feel free to watch it as many times as you want. Comment on it. Comment how much you love these sweet graphics and the sweet life. Anyway, cool. Thanks.